Hey guys, it's Mr. Mailhot. Let's talk about functions. Okay. So we're trying to determine the difference between just a function and a one-to-one function. Just because a graph or an equation is a function doesn't necessarily mean it's a one-to-one function, and vice versa. We just recently took some notes. They look kind of like this, if you remember. Where for functions, that's the relationship between two variables where each input has an output, or each value in the domain has a value in the range, only one value in the range. We do that by testing, we call it the vertical line test, something you probably learned in Algebra 1. Pass your pencil in the vertical line along the graph, and if it touches more than once, it's not a function. If it only touches once at any point, then it is a function. Similarly, one-to-one is kind of the opposite of that. It's if every value in the range, the y values, if every y value has a single output value in the domain or x value. And we test that with a horizontal line test. So same thing, you slide down. If it touches more than once, it's not a one-to-one. If it touches only once, it is one-to-one. Let's try a couple. Let's try number 6. So, is it a function? Horizontal line test. Ready? Let's see. It looks like as I go along, there's no points where that line touches my pencil more than once. It doesn't overlap. So, is it a function? Yes. Now, is it a one-to-one function? Let's go horizontal line test. Slide your pencil up and down. Check it out. Really, no matter where I'm at, it's crossing that horizontal line at 2 places. I can go even way down here to the bottom, 2 places. So, is it one-to-one function? No. Domain and range? Well, domain is your x values. So check those x values. What's the smallest x value that still touches my graph? This one doesn't have arrows, so it does actually stop right there. -3 is the smallest. What's the largest? Well, let's see, looking like at 3. Everything in between there is good. There's nothing on these outsides that touch our graph, because it does stop here. That's what those solid lines mean. So 3 to 3. Solid brackets, because those are, I could physically draw my pencil through there. Let's go range, y values. Remember, start lowest and work highest. So I'm seeing nothing down here. The smallest number that we can cross through our y-axis looks like it's that -3. Interesting. Different -3 though than the domain, right? This was x values. This is y values. Highest value in the range, well, let's see, we're good going up through here. Y values, 3, 4, 5. Okay, you might think, again, there's something up here, but no, they're not arrows. That those dots means it stops. So the highest y value it goes through is 5. Let's do one more. Let's do number 21. I know these are numbered weird. It's all good. Number 21. Is it a function? Vertical line test. Let's go. I think so. There's something kind of funny going on here in the middle. It looks like it might go straight up and down, where your pencil might cross more than once, but if you were able to zoom in, it is still at an angle. So, yes, it is a function. Now, is it a one-to-one function? What do you guys think? Think about it for a second. I would say yes, because even though this looks like it's going to flatten out, which means like your pencil or that vertical or horizontal line would be touching more than once, it will be increasing ever so slightly, even though it looks like it's flattening out. I mean, you can kind of tell it's still going to be increasing. So, also one-to-one function. Cool. Domain. Well, domain is your x values. Okay, this one does have arrows, so it's going to continue on forever in both directions. So I could draw those lines to check all the way out from negative infinity, all the way out, positive infinity. Practice your infinity signs so they look better than this. Range, let's see. Okay, it looks like it might never get up here, but I guarantee you, if we were, since we already kind of, from one-to-one function, we said this is still increasing just slightly. If we were able to go out far enough, it would eventually get up to these values. And if we could go out super far, it would get up to those higher values. So this also is negative infinity to infinity. All right, guys, that's it for now. Come to class with questions. Be ready to learn. Remember, we're mathematicians. We can do anything we want. See you later.